Think about the fastest thing you have ever seen: a jet, a bullet, a lightning bolt. Now, imagine a machine that has been screaming through the dark at 38,000 miles per hour for nearly 50 years without a single pit stop. You clicked because you want to grasp the true scale of Voyager 1's journey, a distance so vast it makes our entire planet look like a speck of dust in a hurricane. Sounds like science fiction. In fact, this is the brutal reality of our furthest reach. The central paradox is that while Voyager has traveled 15 billion miles, it hasn't even left our sun's neighborhood. Before we track its path into the abyss, tell me, what city are you watching from tonight? Let's map the trail of the lonely traveler. To understand where Voyager 1 is, we first have to understand the sheer momentum of its departure. Launched in 1977, the mission was designed to take advantage of a rare planetary alignment that occurs only once every 176 years. This grand tour allowed the probe to use the gravity of Jupiter and Saturn as a slingshot, stealing a tiny bit of their orbital energy to propel itself toward the edge of the solar system. NASA data confirms that Voyager 1 is currently traveling at a speed of about 10.5 miles per second. At that rate, you could travel from New York to Los Angeles in less than 4 minutes. The first major mechanism of this journey was the gravity assist. When Voyager 1 flew past Jupiter in 1979, the planet's massive gravitational pull didn't just bend its path, it acted like a cosmic whip. By the time it reached Saturn in 1980, it had enough velocity to escape the sun's gravity entirely. This means Voyager is on a one-way trip. It can never come back. The second best point to establish here is the pale blue dot. In 1990, at the request of Carl Sagan, NASA commanded Voyager 1 to turn its camera around and take one final photo of Earth from 3.7 billion miles away. Our entire world appeared as a fraction of a pixel, a tiny blue light suspended in a sunbeam. But the real drama lies not in the distance it has covered, but in the invisible wall it hit in 2012. We realized that the empty space between stars isn't actually empty. It is a battlefield of particles, and Voyager was about to cross the front line. That realization would have been enough to make the mission a success. But what happened next made the journey through the planets look like a stroll in the park. We realized Voyager was entering a territory where no human-made object had ever survived. While Voyager 1 was sailing through the outer reaches, it was simultaneously measuring a violent transition. This is the heliopause. Wait, before we calculate the probe's final exit into the galaxy, if you're finding this breakdown of NASA's greatest feat fascinating, hit subscribe. We're decoding the cold reality of the cosmos every week. For decades, Voyager lived inside the heliosphere, a massive bubble of solar wind and magnetic fields created by our sun. This bubble protects us from the harsh environment of the galaxy. However, in August 2012, NASA's Deep Space Network received a staggering set of data. The solar particles around Voyager suddenly vanished, and the intensity of galactic cosmic rays, high-energy particles from exploding stars, surged. This leads to the realization of interstellar space. Voyager 1 had officially left the sun's protective bubble. It is now swimming in the interstellar medium, the matter that exists between star systems. This transition is not a clean line. It is a chaotic boundary where the sun's breath meets the wind of the galaxy. The cumulative math of this isolation is terrifying. The third major mechanism keeping the mission alive is its radioisotope thermoelectric generators, RTGs. These are not batteries. They are small nuclear furnaces that convert the heat from the decay of plutonium-238 into electricity. Every year, these generators lose about 4 watts of power. NASA engineers have had to perform mission triage, turning off cameras, heaters, and non-essential sensors to keep the vital heartbeat of the probe alive. The real drama lies not in the hardware we can see, but in the aging software that is currently failing. In late 2023, Voyager began sending back a garbled 0101 pattern instead of usable data. NASA's aging team of engineers had to dig through decades-old paper manuals to figure out how to patch a computer that was built before the invention of the modern smartphone. This is the peak of the Voyager mystery, the Oort cloud boundary. This is the highest informational value I can give you. Despite the headline saying Voyager has left the solar system, it hasn't even reached the final gate. NASA scientists distinguish between the magnetic edge, the heliopause, and the gravitational edge. The gravitational edge is the Oort cloud, a massive, spherical shell of icy comets that still orbit our sun. Even at its incredible speed, it will take Voyager 1 another 300 years just to reach the inner edge of the Oort cloud. To exit the cloud entirely and truly leave the sun's gravitational influence behind, that will take another 30,000 years. The climax occurs when you realize the golden record's true purpose. Bolted to the side of the craft is a gold-plated copper disc containing sounds, images, and greetings from Earth. Because space is a vacuum, there is no wind to erode the metal and no moisture to rust it. NASA estimates that the golden record will remain readable for at least 1 billion years. The climax of the journey is not a destination, but a state of being. Voyager is not going anywhere in particular, it is simply existing in the void. In about 40,000 years, it will pass within 1.6 light-years of a star called Gliese 445 in the constellation Camelopardalis. After that, it will continue to orbit the center of our galaxy for eons. The reality of 2026 is that time and silence are 80% of the mission. The moment we lose contact, which NASA expects to happen by 2030, the probe will become a silent ghost ship, a metal fossil of the 20th century. We have traveled from the 1977 launch pad to the 15 billion mile marker in interstellar space. The resolution here is understanding that Voyager 1 is the ultimate monument to human curiosity. It is a dynamic, aging fabric of 1970s technology that defies our human need for closure. NASA's missions have shown us that we are capable of reaching into the infinite, even if we cannot follow our creations. You now have the roadmap to the abyss. You know why the gravity assist was necessary, why the heliopause was a shock to the system, and why the Oort cloud is the final, unreachable frontier. The expert status only comes after the very active work of realizing that Voyager is a reflection of our own fragility. Bring your expectations down to earth. Focus on the fact that we can still hear its faint, 20-watt signal across the void, so your wonder can actually take flight. But there is one thing I did not mention at the start of this video regarding the Voyager 2 sister ship. While Voyager 1 is further, Voyager 2 is the only probe to have visited all 4 giant planets, Jupiter, Saturn, Uranus, and Neptune. Together, they form a pincer movement of human knowledge, exploring different sectors of the interstellar medium. If Voyager 1 is our scout, Voyager 2 is our historian. Navigating the transition from amazed spectator to cosmic thinker is the hardest part of the journey. It requires you to stop being afraid of the cold distance and start being awed by the fact that we sent a piece of ourselves into it. If you can master this perspective, you won't just see a probe, you'll see the first step of a journey that never ends. You have the data and the framework, now you just need the discipline to keep looking up. Voyager 1 is not a machine that failed. It is a machine that refused to stop. The distance Voyager 1 has covered is staggering, but the data it's sending back right now is even stranger. Watch this video next. It shows you the exact code NASA just used to fix Voyager's 50-year-old computer from 15 billion miles away. Click it now to see the ultimate long-distance repair.